The final mitigation technique we're going to talk about in this session is CPSM mitigation. And we're going to outline a CPSM solution to the skewing problem based on the interaction between MQ triggering, or the CTI transaction, and CICS itself. The configuration for inbound MQ work using triggering is shown on this slide. Each CICS region acts as an independent consumer from shared queues. So that independence can create the unbalanced workload distribution that we've seen because, as shown here, the CICS that happens to be on KEC 2, which is a Z196, is getting the vast majority of the workload. Now the queues here are important. We have the application queue, and the application queue is what fires the trigger event. A message being put to that queue will create a trigger event which will create a message in the initiation queue. The initiation queue is what the CTI transaction is listening to determine if there's work that needs to be processed. We're going to talk about two different types of triggering here. The first is trigger on every, which is not as commonly used as trigger on first. Trigger on every means that for every message that's put to the application queue, an initiation message is sent or created by MQ, and a CICS transaction is driven from that. Trigger on first, when a message arrives on the queue that takes the message depth from 0 to 1, or at certain other intervals, the arrival of the message will create a message on the initiation queue, and that will in turn trigger the transaction within CICS. So, the trigger monitor CTI actually listens on the queue, as I said before. It gets the trigger message, and then it issues a CICS start for the transaction that's associated with this trigger. This will start up the the business transaction. In a trigger on every, what we would see is that we would do the MQ get for the request message, the business logic is processed, the MQ put for the response message is placed, and then the transaction ends. The fastest CTI is going to get the most work. So if it happens to be on a faster processor, if it happens to be on a more powerful LPAR, doesn't really matter. It's just going to get most of the workload. So trigger every, what we would like to see is this type of configuration that's shown here. The TORs, or the transaction, or excuse me, what used to be known as the terminal owning regions, only these of course are not running on based on terminals, actually run the CTI transaction. Each one will act as an independent consumer from the shared initiation queue. Each distributes the starts across all of the AORs within the Sysplex. And from that, if you are using one of the link neutral methods for distributing workload under CPSM, you will get a very balanced and even workload distribution. This bypasses some of the problems that we have observed with CICS, of course, and MQ trying to process everything local. This will actually distribute the workload for you, so you get that even distribution. Now, for a trigger first or depth, which we don't see very often, what we see is this type of a model. We have the start of our of our transaction. We have the get of the trigger message. It issues the exec CICS start, but the business transaction itself runs a little bit differently. The business transaction does an MQ get for the request message, processes the business logic, puts the response message, and then goes back to see if there are additional messages on the queue that need to be processed. This is a more typical workload than trigger every. And the reason it's more typical workload than trigger every is that with this model, you don't initiate a new transaction for each message that comes in. So it's somewhat cheaper in terms of CPU. One of the things that has been suggested to take care of this or to help mitigate the workload distribution problem is to actually alter the way the CICS transactions work a little bit, if it's possible within your environment. What we have recommended here is we have what we call a staging transaction in the middle. The staging transaction is where the MQ get and the MQ put reside and the loop that takes you between them. Within that loop, you're going to want to do an exec CICS link to start the business logic that takes place. Now, the business transaction will process one and only one request message, and because of the way CICS and CPSM works, that link can then be distributed across all your AORs. So that while you may get some workload skewing from the standpoint of the staging transaction that takes place, you will see a much more even distribution of the business logic, which is frequently where a lot of the CPU resides, a lot of the cost to your environment. So, this is one of the preferred configurations for the first or depth staged. We have what we call a CICS QOR or QOwning region. The QORs actually run the CKTI and the staging transaction themselves. Each acts as an independent consumer. Each distributes the links across all AORs available in the Sysplex. This gives you a balanced workload distribution. Again, we're talking about the link neutral workload distribution capability that CICS CPSM has built in with it. So this gives you an idea of another mitigation technique. So, from a highlights perspective, this solution uses the proven technology for CPSM routing. Each TOR or QOR uses the link neutral goal algorithm. It selects the target AOR based on the AOR load and health at the time. Does not prefer local, which means that it could be routed anywhere in your environment, and it gives you a very even distribution. You have the XCF MRO for remote starts or links. It's a high-performance System Z Sysplex technology. It uses the coupling facility instead of TCP/IP. It is very fast. And you can use the Sysplex optimized workload routing. It's highly responsible to transient variations in your environment. You suddenly start picking up a lot of load in one of your LPARs, it is very responsive to that and start shifting future workload to other LPARs to keep with your goals in mind. Continuous operation and high availability through MQ shared queues. We really have glitchless recovery. Any CICS region that's connected to any queue manager in our Plex can get to those application queues. We have instant redistribution of workload because of the CPSM factor. And in-flight messages can be backed out and restarted in another CICS region. If you are using CICS 5.1, 4.2, and MQ 7.1, you have the ability to use group units of recovery with this solution. It's very high throughput and it will exploit all your available capacity anywhere within your environment. So you don't necessarily see hot spots on one LPAR and you don't necessarily see very low spots or very low utilization in others. So in summary, it's important to remember, as I said at the beginning, MQ is a message delivery system. It does not try to balance the workload. It just hands it off to whoever says that they're ready to receive it. Balancing the workload is really attempting a technical solution for what is often a pricing problem. And one of the things that I personally caution people on all the time is to beware spending a lot of effort for a solution to a temporary problem. If, for example, I am upgrading one of my KECs in my environment to an EC12 and the other is a Z10, I know I'm going to experience some workload imbalance for a while. Do I want to spend a lot of time and money smoothing that out for a situation that may only last a couple of months? It's a trade-off. You need to think about how this is going to impact your environment in the future. You can turn off performance improvements like put to waiting getter, but that impacts all the applications, not just the ones that are dramatically skewed or that are making a difference to your business. There are some mitigation techniques that can help the overall environment. Gateway queue managers, for example, using CPSM to make appropriate routing decisions, or even MQ clustering is a relatively simple and straightforward tool that you can use to help you with this. And with that, I would like to say a special thank you to Steve Hobson for the CICS CPSM expertise and the wonderful initial graphics, to Mark Taylor and Jean Kilthau for their patience and guidance on the rest of these foils. Thank you very much.
For more information on some of the subjects covered in this presentation, please follow these links.